Hello everyone. Feels nice to be in Malaysia today, even though I'm Malaysian. But I'm a bit nervous actually. I guess let me just take a breather for a bit. But today's topic will be a little bit of me yapping about AI stuff that I've did for the past few months, I think. Only been like 6 to 7 months doing AI one research. So I guess we can do a little bit like introduction. So myself, my name is Amran. I think you might know me online as Vice Firdaus. I work as a security analyst in the offensive side at my current company. And before this, I was a web developer for like 6 years. And then I jumped into cybersecurity. Right now I'm working for like 1.5 years, I think. So it has been a pretty good journey in cybersecurity. I really like reading like code base and stuff and finding vulnerabilities compared to doing black box. And as I said before, I'm a security analyst, but I'm also a part-time token gambler. So in a way, I might have a gambling addiction. So let's lock in. Okay, a little bit of a disclaimer. This slide was actually made, most of the contents were made before the GPT 5.5 mythos hype. So at that time, I think there wasn't much companies that were looking into this, other than maybe I see a lot of Expo and etc. So the models that I used were GPT-03, GPT-5 through GPT 5.3, 5.2, etc. So basically, this whole thing was funded by my own self because maybe I have a lot of free time to actually do this kind of things, and also it's my passion to actually see like how far can you go with AI to actually find vulnerabilities in big code bases. So as the title says, it's what? Spray, pray, and validate. Basically, my idea of spraying is like you want to create a lot of hypotheses from a code base with LLMs, and my definition of praying is that you pray you found something. Yeah, basically gambling in a way. Yeah, maybe it's gambling. Yeah. So the next thing is to actually validate the things that you have found. We'll go deeper into it, like here. So you might be thinking, why spray? The thing with code base, a very huge code base, I like to think of it as a very huge search space. Okay, so you got things you can explore. There's multiple subsystems, like you have auth, you have maybe functions to actually create something, function to actually run something. So I like to think of it as a very huge search space. So the thing about spraying, right, is that I think that LLM can be a very good way to actually exhaust these search spaces. So basically, like when you got a very big, huge space in the code base, you can just use LLM. Hey, you go here, check this one, bring out the most hypotheses you can from here. Just put everything inside of it. So yeah, I think the best part of LLMs is that they don't get tired. When you run LLM to actually search for that specific space, like, I don't know, maybe it's just my imagination. I like to think of it as a very big search space. So if you exhaust the space, I think compared to normal humans, when we do research, we go into a code base, we try to understand how this function works. Eventually, after, maybe it depends on the person as well, after a few days you look into something, you get tired of it. So with LLMs, I think it's much easier for you to actually go through the code, in my opinion. So again, the goal of this research is not perfect accuracy, because I believe LLMs still have a lot of stuff to actually be good. Maybe Mythos could be good, maybe GPT 5.5 could be good. But the idea is that I want to generate a lot of leads from the code base. Basically, I just want a lot of hypotheses from code base so that I can exploit something that I found. So in a way, maybe it's similar to fuzzing. Like you are trying to like get something out of a very big code base. Yeah. But cost-wise, in my opinion, it's very expensive and token-heavy. I think especially on a very large code base, it could take around $200, I think, per run, if I remember correctly, yeah. So yeah, it depends on the code base as well. But I hope you understand why I wanted to do spraying, okay? So another question, why do I validate manually? Why not use LLM to validate? Well, there was a case where I think it was a CTF challenge previously. It was a 0-day in some web frameworks. So the thing with AI sometimes is that the validation that they do isn't very good. So you need a way to handhold the AI. Like, okay, you have this specific thing to look at, and then you tell it, maybe you can try this, okay? And then basically, what I wanted to do was actually do the exploit part by myself, because I believe maybe some of my knowledge or my hand-holding methods could help the AI to do better. Also, another thing is that when I do my own exploit, I want it to have a POC at least, so that when you send it to the developers to fix it, they don't like, okay, this is AI slop. Even now, even you see a lot of reports that are not valid by AI, and people just submit it right away. And I think that's not a good thing to do. So in a way, you keep the devs happy by having a POC. Usually when I report vulnerabilities to maintainers, I will always include a pull request so that they can quickly fix and give me a CV or something. So yeah, like I said previously, some exploit path that the, I think if we told AI to actually do it, they might not be able to do it because of the constraints that, the knowledge that they have. So yeah, in a way, I just want to keep myself in the loop for the exploit development, but for the discovery, it's done by the AI itself. So yeah, let's see. I think I should go a bit slower. Okay, let's start a little bit. When did I start doing LLM stuff? Basically, last 2 years, when GPT-4 first came out, I tried something called, what is it, Pandas AI and Llama Index. So Pandas AI is basically like a library for you to query Excel sheets and stuff. So Llama Index is like you can have rack database. So I was building something to query the Hayabusa forensic timeline generator output. So I can say at that time, hey, this thing is pretty good at searching and querying text. So maybe there's some future to it. But at this time, I think the model is very dumb at understanding and writing code. So it couldn't be good yet at finding vulnerabilities. But I do use it for like, as a replacement to Google search, yeah. So this is just a pet project that I made. It's pretty cool, I think, at that time. So I think it was last year May. Last year May, the release of GPT-03. I think with O3, models start to get better at understanding and writing code, okay? And then I wanted to try something. At that time, I wanted to like get into vulnerability research, like how do people actually find 0 days CVEs in very big code bases. So actually at that time also I was like contemplating, like I don't know what is the path of my career, and so I was just playing around with stuff. So I can say at that time, um, I was looking for a very quick way to pull out the leads out of the code base. Okay, so I was looking for ways to quickly pull out leads. So my first thought that came to mind was AI, because O3 is that at that time it feels good to actually be writing code with it, and you can understand the code I think quite decently. So yeah, from there I just started building something. Yep. So the first thing I built was a single agent. So in my opinion, let's not talk about opinion first. Let's just talk why did I build a single agent. So a single agent at the time I built, it was for only to save time on CTF challenges. Before this, I was a very active CTF player. Now I've retired because of AI, I think. AI is solving everything for some reason, which is a bit sad for people who play CTF now. So my first agent was built with LangChain. I'm pretty sure you guys have heard of it. Basically, it's a framework to build AI agents. Okay? So LangChain at that time, it was a very naive implementation of mine. I didn't understand much what was going on. But yeah, that's basically for the initial why. So for the single agent in CTF, my methodology was very simple. So basically, you have a challenge, okay? You have a challenge, and then from that challenge, I think I can guess what kind of challenge could this be, what kind of idea I could test out, okay? So most of the time, when I play a CTF, there's a challenge. I would just run the AI first on it and actually gather all the information. And also, I give it my idea so that it will try my idea out in a way it will tell me if it works or not. I think in CTF, when you are running out of time, like you are running against the time, you should try everything that feels relatable to the challenge. So in a way, AI helps with that kind of problem. So yeah, basically they never get tired, like I said. So if you have a challenge, CTF challenge, you put your ideas in. But of course, you need to have a prior knowledge. Means that maybe you have seen this challenge somewhere before, and then you just tell AI to do this, and if it works, then it works. If it doesn't work, then maybe it's a different way. So in a way, it's a way to save time. Of course, if you can guide it properly and you can manually intervene, that's actually very nice. So another thing, so after that, after like I had a few successes in CTF, solving challenges with that kind of methodology, I did try to make it for one research. Because again, I repeat myself again, I don't want to spend too much time on a code base. I just want a fast in and fast out. Okay? I just want push. Yeah, just get everything. So I built a single agent. I think the prompt was pretty naive at that time. I think it was like combining every one classes in one prompt, which at that time it did have a little bit of success. Maybe because at that time there wasn't much people who are using AI to find vans and stuff. So yeah, I enjoyed the meme by the way. Let's see. So my first, actually it's not my first, one of the CVs that I found, I think it was last year. This was actually found by a single agent. And a little bit, I'll just go a little bit on the technical details, and I'll tell you why in a second. So apparently the framework, the coordinator for framework, they have something called image magic handler. When you want to resize your image, you can choose to use image magic. So let's say if a developer built something, like they have an application that allows you to upload images, okay? And then if it does not sanitize the file name, your file name could get executed directly into the shell, basically the exec command. So the thing with that is that in Coordinator 4, there's something called sanitize file name, but that sanitize file name does not sanitize shell metawrite characters. So yeah, that's actually the thing about framework is that it's a bit hard to say like what is right and wrong, but I think it's something that most developers might trip off in a way. So another CVE that was found by the single agent, I think it was last year as well, OctoSTS. The OctoSTS is actually a very interesting exploit in my opinion, because it's an authenticated SSRF and you can see the response right away. So if let's say the web application is connected to internal applications, you are able to query the internal applications. Another funny story was that, I'm not sure if I should share this, maybe it's fine. My previous company's team wanted to use this, so I just checked into it. Apparently it had this vulnerability, so we decided not to use it, I think, maybe, not sure. But basically, for AutoSTS, you need to have it publicly facing, because you need to be receiving webhook requests. Okay? So in any way, if someone were to do like showdown or something, and if they find a AutoSTS instance lying around, they could just maybe request the internal application if they want to. So this one is actually pretty interesting, but it's just that, yeah, I don't have the explanation here. I hope, yep. So this one I think is a very shallow bug as well. Moodle, yeah. This Moodle vulnerability actually I reported it last year, but it only became a CVE this year because Moodle have their own timeline to actually fix stuff. So this one, the details are very simple. It's basically like the previous one. It's just a string concatenation. So some of the functions have escape shell arguments, but one of this particular variable does not have escape shell arguments. So anything that goes through that turns into a code execution. Okay? So it's a very simple bug, I think. This one is also authenticated, so it's not very fun. I think the takeaways from a single agent setup is that I do realize that agent performance gets worse as time goes on. Like if you give it a very difficult task and it will keep doing that thing and they couldn't solve it, and eventually they won't even solve it, okay? Because of context dilution, okay? As you have more data going into the context, the agents become much more dumb, I'd say, and it become much more slower. So another thing that I realized was, when you build an agent, you have tools, okay? Tools, and then these tools, let's say you give it a read file tools, okay? So the file that the agent chooses to read can be pretty random, which I don't really like because, again, I want to cover everything. Especially in large code bases, you don't want it to be reading random files and focus on that one random thing. You want it to be have full coverage. So another thing that I realized is that the agent itself is that it usually misunderstands the threat model of the application. I mean, it does not know what is supposed to be a vulnerability. Like for example, in a framework, in a Coordinator 4 framework, it's very hard to understand the threat model unless you give them RFC or docs, like how you are supposed to actually build something out of Coordinator 4, for example. So That's the thing. It's very hard for the application to actually understand the threat model of your application. Another good thing, I think I've kept saying this so many times, agents are relentless. Like they can never get tired. If you have something to look for, you can just ask the agent, look for it, but make it very specific. Okay? Yeah. Let's see. Whew. Yeah. So we've talked about context solution. I think context solution is something that most people should know by now because of the hype recently. So the thing with context solution is that, like I said previously, a single agent, you can run it for hours, even, I think hours max, okay? But you won't even solve the problem because you hit a limit, it becomes dumb, and it becomes slower as time goes on. I think in my opinion is that a single agent works very best when you have a bounded task, like a very narrow, clear, specific objective, okay? Like for example, if you were to ask someone to go to the shop and please, let's say you have an intern, you ask your intern to go to the shop, please buy me something that is sweet. Instead of, your question should be, you tell your intern, just buy me 100 plus. By the way, 100 plus is a drink, Malaysian drink. Maybe I should have used a better, maybe Coca-Cola, yeah. So basically, you want to tell your intern to actually like, don't do very vague kind of instructions. Instead, make it very specific and make it a very small scope in a way. So yeah, basically don't make one agent do everything. Instead, make it do one thing well. So I was thinking like, maybe let's make things better. Because at first I didn't believe the hype of the multi-agents and sub-agents because I think, oh, I need it. I feel like maybe it's just hype. Maybe it's just adding more complexity to my current workflow. Because the single agent has been working quite well for me. But then I wanted to try something. Maybe what if I can separate more of the code base and some of the roles of the agents so that they have more like, they can do their separate jobs very well, okay? So yeah, basically I want every agent and sub-agent to actually have a very clearly defined scope with a narrow responsibilities so that they can do that one job very well. Yeah, basically this is just a diagram to show like how it could make things better. Like a single agent, this one is fine. And then if you want to make even better, you add multi-agents, and then you add multi-agents planning sub-agents. Basically, just spawn a lot of agents. Yeah. Just spend a lot of money, yes. So my multi-agent setup were built using Pydantic AI. At the time, I had two choices, either LangGraph or Pydantic AI. And I choose Pydantic AI first because the syntax is much easier to read, and also it doesn't have much syntax sugar. You can do very raw kind of routing, and it felt very natural to me in that case. And also they have structured output out of the box. I think LangGraph also have it, but I just like Pydantic AI more. So yeah, the methodology of like building that whole multi-agent setup was to actually generate a lot of hypotheses from the code base and validate it likely, and you validate it manually for actual exportability. Okay? So yeah, basically I have hunter agents to actually report anything suspicious. Just, you don't have to validate it. Like the agents are supposed to only find weird stuff, and they are not supposed to validate the weird stuff. It is our job to actually validate it. So the goal is to find web-based vulnerabilities and to be language agnostic. Basically, I just want it to work on any code base that I'm running on. Okay. So the first iteration, I think, yeah, I did a baseline context because I did an agent to actually get a baseline context for the code base. Because like I said previously, the agent does not understand the threat model straight away. So you need a way to actually let the agent understand how the application goes in and out. So I also use AST parsing with 3-seater, but we'll go on why I don't like it later. And rip grab, which is basically a faster grab. And then you have a 9 variety class hunters, which basically generate hypotheses for specific vulns. Yeah, basically just a lot of hypotheses from the code base and very differently, yep. Oh, by the way, AST is abstract syntax tree. So another thing, I wanted to try to look into Chrome. Like, I'm very bad at binary exploitation. I admit that I'm not so good at binary exploitation. So I wanted to find like logic bugs in Chrome. So I focused myself on these 5 categories. So basically, I just built like 5 one-class hunters to actually like pull out something from the Chromium code base. And it is, I think, quite a lot of stuff that I found, but I didn't report everything. I just report the things that are, like I feel like this could be a good POC to be reported. And again, the methodology is the same. Generate a lot of hypotheses, validate it lightly, and you validate it manually. Basically, create your own POC. So this is what is found by the setup. One of it, booty base. I think this one is pretty interesting because the exploit only work on the cloud deployment. For some reason, their cloud deployment does not have a separation. Like, if you are able to get RC on their application on cloud, you are able to get someone else's credentials as well. Yeah. So basically, that's the CouchDB, or I don't think you can see it. But basically, you can query the CouchDB, and you can get everyone else's credentials from here. So again, eval, in my opinion, is still a shallow bug, but it's still a very cool finding, in my opinion. But it's fine. So the Chrome CP that I've found a few months back, I think I reported in January, and then it got fixed on February, I think. I think it was a very shallow bug. Like, if I had to describe it to you, this function, you have a lot of functions, like 5 functions. Each of these functions have their own checks, security checks, but one of it does not have that security check. Basically, it's just missing that one check. So apparently the LLM able to surface that, which is pretty cool, I think. But to me, it's just a shallow bug. But the thing with browsers like Chrome, Mozilla, they do defense in-depth kind of a bug hunting. Like, if you cannot exploit it directly, if it's something that comes after the renderer process, you could still report it. So this is something that works only after you actually compromise the renderer. By the way, compromising the renderer means that you can get RCE to make it easy, in a way. Yeah. So the takeaways from the first iteration is that multi-agent, I think in my opinion, it worked well up to a certain point, but it's just that I feel like it's still very random. Like, if you have a very big code base and then you have, like, for example, 9 hunter agents, those 9 hunter agents can get overwhelmed and they can actually like still be random, okay? They can choose to focus on something that is a bit, I would say, maybe it's not useful for them and they just keep exploring that path. So I wanted something more like smaller in a way, that you can actually generate hypothesis from a smaller scope. Another thing is that I feel like when I built the AST parsing with 3-seater, I think I was having a lot of issues making it work across languages because I think it differs from languages to languages. There's some language that have a very specific imports, like weird patterns, and their data flow behavior can be different as well. I think the hardest part was actually making the crossfire tracking works nicely. So I just scraped the AST parsing out of the code base. So I made things even better. I tried to make things even better, also even more expensive. So I scrapped AST parsing and I only used regrab. Another thing that, a reason that I used regrab was, hey, why did this, let's say, Cloudy codecs, why are this like this applications they still use grab? There must be something that the models might know better compared to giving AAC structures. So, okay, just to make it simple. Basically, I think LLM models understand code better than AAC structure. That's just my assumption. I'm not sure of it, but because if you are trained on code base, then maybe you have a much better idea of the code itself rather than the AST structure. Okay. Also, another thing, since I removed AST parsing, I added LSP support. Basically, LSP is like I added it as a tool. Like if you wanted to find a reference to a function, you can just call the LSP to actually find that specific function in the code base. So in a way, it helps the agent to actually find stuff that relates to the function. So I think this is another one that costs a lot. So before the Scout, I had a planner agent. We go into the graph after this. I had a planner agent to actually split the code base into a smaller subsystems, and then each of the subsystem gets agents that generate hypotheses for each of the subsystems. I hope that makes sense, but we'll just see later. So why did I do this? Basically, I just want to make sure that I cover every part of the code. I want to make sure every part of the code, like every subsystem of the code, gets full-on focus from the agent. Okay? Basically, just generate even more hypotheses. So basically, the code base, you got the LSP and Scout. LSP basically just to, at first, is to detect like what kind of code the code base is using. Of course, the indexing, I think I tried indexing before. It doesn't take too long, so should be fine. And then you have a planner agent to actually split the code base into multiple subsystems. And then, like I said, each of the subsystems get an agent to generate hypotheses for them. Okay? So when you generate hypothesis, you can verify it very likely with LLM. And then you can manually validate it. Yeah, it's the same thing. Basically, you just want every part of the code to be touched by the AI. Okay. I think the final takeaways of the research is that I think you should use LM like a tireless fuzzing engine to absorb the search space. Like, for example, if you want to test something out on this specific function, by all means, put your idea in and just boom, like legit. For agents and sub-agents, make it a very small task, a very small scope, a simple tools, okay? You just make it like, you make sure that the task, the functions that you give, the instructions that you give is super simple that the AI can understand it well, okay? Like I said previously, basically you are saying something to an intern, a very specific thing rather than a vague thing, okay? Avoid being too language or project agnostic. I think this is the mistake that I've learned throughout this research, is that maybe it's best if I don't make the project to be project or language agnostic, because I think it is still very hard to find deeper vulns or bugs, okay? As you can see previously, those ones, I think, in my opinion, most of it are shallow ones, in my opinion. So if you want a better one, then I guess maybe don't do it like language or project agnostic. So I think this is the best one. If you do have a code base, like you have an internal code base at your company, you build a specific harness for your code base, like you are a developer and you want to understand like how, let's say you are a developer, and then you understand how your application goes in and out, right? You understand every function inside of it. Instead, you build like a very specific harness, like agents and stuff, build it, and put all of your knowledge inside of it. I'm pretty sure you'll find a lot more like very deep vulnerabilities. So like at your company, like you have RFCs, docs, certification. By all means, just build your harness agents around that, and you'll be able to find deeper vulnerabilities. And in my opinion, if you build your harness good enough, it is actually much, much better than fine-tuning. Actually, much better. Like, if you are able to build something like around that code base, you are able to find deeper vulnerabilities. Okay. In the future, I guess, LLM will improve as they get better at reading, writing, and reasoning. Like, once they get better at reading, writing, and reasoning, they can find, I think, deeper bugs. Okay. Okay. But basically, I just want you guys to actually get this last point. If you can build something around the agents very well, like you build a code-based specific harness, then that is actually very much enough for you to find deep vulnerabilities. Okay? The thing with me, with this project, is that I make it language and project agnostic, which means it works for all code bases and projects. I think it's not a very good way. You're only able to surface very shallow ones. So yeah, by all means, if you have a code base that you want to actually focus on, build the agents around the code base. Okay? Yeah, by the way, harness is code base specific setup tools from docs. Yeah, I think you get my point. Future work, I guess, I think what I didn't mention is that there's a lot of vulnerabilities that were unvalidated from my runs. Some were validated but not submitted yet. Still under embargo, blah, blah, and had no response. Remaining leads are probably kept for future work. Yeah. Maybe, yeah. Yeah. I think that a friend of mine, a junior of mine, got a CVE today. So that's pretty cool. Maybe, yeah, it's fine. I have to put it in their slide. By the way, if you have any questions, feel free to ask now. Yeah.
Yeah, once again, if you guys have any questions, raise your hand. We will hand over you the microphone. We still have, do we still have here a couple of minutes?
Yeah. We have 2 minutes for questions.
Hi, my name's Phil. Thanks for your speech. You didn't come across nervous at all, so thanks. Just a quick question regarding your hypothesis. Are you able to explain a little bit about the evolution that you might have noticed as you were going through those?
Sorry, I can hear you.
Regarding a hypothesis,
Okay.
were you able to expand upon some of the evolution you may have noticed as the agents were coming back with different generations of hypotheses?
You mean like as the models progress, like is there a difference in hypothesis that I found?
Yeah, did you notice they were learning or getting more accurate, or did you see a difference as they were essentially perhaps getting better at generating hypotheses?
Actually, yes. I think starting from GPT-5, it has become a lot more reliable. Like before this, O3 had a lot of false positives, but when it comes to GPT-5 and above, in my opinion, it becomes more reliable and you're able to capitalize on that manually. Yeah. I think I do see an evolution, yeah.
Great, thank you.
There is one more question behind, so we take the last one and we'll proceed to the next speaker.
Assalamualaikum and good morning. I have a question. Do you ever play with others' models that is not OpenAI or Anthropic? For example, some Chinese model, perhaps?
That's a good question. Actually, I've never tried Chinese models, but I did try cloud for a while, but it was burning my pocket too fast. so I just make use with GPT. So probably the answer is mostly no. Yeah.
Thank you for the question.